All right, so here are a couple more. Number 82. So this is a binomial, not a trinomial, right? But in this factoring completely section, you'll see a mix of some different things. So I wanted to show you and just review a little bit on some types of factoring that we've done before. Okay, so if you see a binomial, then and if you see any kind of polynomial, right, you want to always check for a GCF first. So here we have a GCF of W, so we can factor out a W. Then our leftovers will be 9 minus W squared, right? When we divide both of these by W, that's what we get, okay? Now this is a difference of two squares, right? 9 is a perfect square, W squared is a perfect square, it's a difference, we're subtracting. And so we can set this up like this, right? And so the square root of 9 is 3, so that goes here and here. The square root of W squared is W, so that goes here and here. And then remember, with the difference of two squares, you always put a plus and a minus. It doesn't matter which order. And so that's as far as we can go, right? We can't factor this, nor can we factor this anymore. All right, let's take a look at 100. So here, we definitely see we have a common factor of 3, right? They all have a 3 in common, so we're going to take out a 3. They also share an x. Take the one with the smallest exponent, which is x to the first. And then they also share a y. And the smallest exponent is y squared, so we'll take that out. So we're going to put our leftovers back inside. So we divide everything by 3xy squared. So this divided by 3xy squared is going to be 1x squared, right? This divided by 3xy squared is going to be negative 1x, right? This divided by 3xy squared is just going to be positive 1. Okay. So now this looks like a perfect square trinomial, right? This is a perfect square. This is a perfect square. The problem is if you square root them and you get 1 and x and you multiply them together and double, you don't get this middle term, right? So it's not exactly a perfect square trinomial. So now we can just check, okay, well, can we find numbers we can multiply to get 1 that we can add to get 1, right? Are there numbers we can multiply to get 1 that we can add to get 1? And that doesn't work, right? The only factor pair of 1 is 1 and 1. If we add those, we get 2, right? So this is actually as far as we can go. We can't factor this anymore. So this is our final answer. Okay, so remember, this is prime, and so that means that we can't do anything else, right? We don't say prime for the whole thing because this was able to be factored to this, but from here on down, we can't do anything else, so we just leave it. All right, and lastly, we have some grouping method review here. So we have a polynomial with 4 terms, and so once again, that's a little different than what we've been doing in this lesson. But in this factoring completely section, we're kind of bringing everything back into the mix just so you can get a taste of how to differentiate and tell, oh yeah, this is this method versus that method, right? Because that's one of the trickier parts about factoring is when do you use which method. So if it's 4 terms, we're gonna check into grouping, right? We're gonna try to use grouping. But always we check for a GCF first. So do we have a GCF? No, we don't. So we can't factor out a GCF. So now we group these terms together and these terms together and factor, right? Factor the GCF out of each of those pairs. So here the GCF is x squared. And our leftovers are going to be x plus 7. Okay. Here our GCF is going to be just negative 1, right? I want to factor out a negative because that's negative. So whenever this is negative or whatever sign that is, that's going to come down in front of your GCF. There's no number bigger than 1 that goes into x and 7, so I'm actually just going to factor out an invisible 1. And then if I divide these by negative 1, then I'm going to get positive x and positive 7, right? Okay, and then as usual, these match up, right? With the grouping method, that's how it should be. So I'm going to end up with x plus 7 in the front. And then my leftovers back inside will be x squared minus 1. So I put x squared minus 1 here. Now, if we look at that closely, we can see that this can be factored more, right? This one's done. It's not a difference of 2 squares, but this one is a difference of 2 squares. So we can factor that more, right? So we can say, okay, well, let's turn that into something like that. 2 sets of parentheses. X plus 7 just comes right down. All right, and then the square root of x squared is just x, so we put that here and here. The square root of 1 is just 1, so we put that here and here. Then we do a plus and a minus, and that's it. Okay. All right, and then we'll see one more. Oops, I have this one. That's from the last. All right, and so let's do the same thing here. So first of all, check for a GCF. So they all, no, A is not shared, C is not shared. So yeah, nothing's going to be in common. So you could move these to the front if you wanted to, kind of up to you, or maybe have to rearrange. But I think this will be okay to keep it like it is if we want to. So I'm going to group these together and these together. Here the GCF is C. So I'm going to factor out a C, and then I'll have A plus X left over. The GCF between these two terms is W squared. So I'm going to factor out a plus, right? And then a W squared. And then my leftovers will be A plus X. And so these match up. So I can bring A plus X to the front because now it's a common factor. And then the C and the W squared can go back inside. So C plus W squared. Okay, now this we can't factor anymore because neither one of them are perfect squares and it's a sum. Here, this same thing, we can't factor anymore. It's a sum. This is a perfect square, but this isn't, and so there's nothing we can do with that. So that's as far as we can go.